Hi future doctors, welcome to the next class. In this class we will discuss coefficient of restitution. It is denoted by small e. So what is meant by coefficient of restitution during the collision means while deriving one-dimensional elastic collision, we got equation number 3. What is the equation number 3? u1 minus u2 equal to v2 minus v1. Relative velocity of approach before collision equal to relative velocity of separation after collision. So from this equation, we can remember this coefficient of restitution. So what is the small e? How it is going to be defined means. So v2 minus v1 divided by u1 minus u2. So u1 v1 initial velocities before collision u1 v1 final velocity after collision. u2 initial velocity of second object before collision, v2 final velocity of second object after collision. So this is the equation or definition for coefficient of restitution. Some people will replace this with minus also. Minus v1 minus v2 by u1 minus u2. Both are going to be same only. So for perfectly elastic, E value is going to be 1. Therefore, you got in that one-dimensional elastic collision this equation. If you keep 1, you will get same equation. For perfectly inelastic, E value will be 0. If you put E value 0, you will get V2 minus V1 is 0. This implies V2 is equal to V1. This one only we said in inelastic collision, final velocities are same after collision. So in between, neither elastic nor inelastic. Then E value will be in between 0 and 1. So this is about coefficient of restitution. If an object is dropped from h1 height, after bouncing back, it is rising h2 height. It will be rising here only. But for our convenience, I am showing here. Object dropped from h1 height, it is rising to h2 height. Then what is the coefficient of restitution, they will ask. So in this, one object is falling downwards and second object is ground. So ground velocity before and after collision, it is 0. Now what is the initial velocity whenever it is touching the ground means u1 is equal to, an object is dropped from h1 height. What is the initial velocity? Root 2g h1. If it is rising to h2 height, final velocity root 2g h2. So downwards velocity, if you are taking it as negative, upward velocity we will take it as positive. So according to coefficient of restitution definition, E is equal to, what is V2 we got here? V2 is 0, 0 minus, what is V1 we got? Root 2g h2 divided by, what is U1? Minus root 2g h1. What is U2? That is going to be 0. So finally you are going to get E is equal to root 2gh2 by root 2gh1. So E is equal to root h2 by h1. Very important equation. So that is coefficient of restitution in terms of falling height and rising height. After one rebound, how much height it is rising means from this equation you are going to get E is equal to root h2 by h1. Then E square is equal to h2 by h1. h2 is equal to E square. If it is dropping from h1 height, it is rising h2 height after one collision. How much height it is rising means E square h1. How they will ask question on this? An object is dropped from 1 meter height, 1 meter height, and it is rising after collision 64 centimeters. Then what is the coefficient of restitution they are going to ask. At that time, we will use simply this equation. E is equal to, what is H2? Second height is 64 centimeters. First height is 1 meter. See here, this is 1, this is 64 in centimeters, meters. Some people won't see these units. Directly they will cancel. 64 means 8 they will write. It will not be like that. So this one you should convert into meters, otherwise this one should be converted into centimeters. 64 centimeter by 100 centimeters. That is going to be 8 by 10, 0.8. 8 will not come. Why? Because its value should be in between 0 and 1. This is about coefficient of restitution. So whenever the small e is coming, so whichever we have given previous equations, all these small changes will be coming. So we will see once what are the changes. We have given during one dimensional elastic collision, V1 is equal to M1 minus M2 by M1 plus M2 plus 2M2 by M1 plus M2 U2. Like that, V2 is equal to 2 M1 by M1 plus M2 U1 plus M2 minus M1 by M1 plus M2 into U2. This is for perfectly elastic collision. If E is going to be added, where we have to add means this one. If it is neither elastic nor inelastic, in place of 2, we will write here 1 plus E. In place of 2, 1 plus E. So here M2 minus M1. So for perfectly elastic, if you write E value 1, again this previous equation you should get. See, now you are going to get E value 1, you can substitute. Previously what we wrote, you will be getting 1 plus 1, you will be getting 2. So for inelastic, perfectly inelastic, E value 0. Same equation you will get if you substitute. Once you can cross check. If E is 0, V1 is equal to what you will get here? M1 by M1 plus M2 U1. E is 0. 1 plus 0. That is nothing but M2 by M1 plus M2 U2. So if you are taking LCM, what you are going to get? M1 plus M2, M1 U1 plus M2 U2. Correct? So this one only we got common velocity for perfectly inelastic collision. Therefore, if E is equal to 1, that is elastic. E is equal to 0, that is perfectly inelastic. This is with E. And in inelastic, we got loss of energy. What is loss of energy formula? We got there delta K is equal to half M1 M2 by M1 plus M2 into U1 minus U2 whole square. So for this, if it is going to be neither elastic nor inelastic, so you will be getting E extra. That E is nothing but 1 minus E square. Again, if you keep E value 1. So if it is going to be E value 1, 1 minus 1, so there is no loss of energy. E value 1 means which collision? Perfectly elastic. If you keep E value 0, that is going to be perfectly inelastic. Again, you are going to get previous equation, this one, if E is 0. If E is going to be given, what is the loss of kinetic energy? Then you have to use this equation. This is about equations related to coefficient of restitution. Then, what is the height rising after n number of collisions? How much time it is taking? What is the total distance it is going to cover? And what is the oblique collision? So those we will be discussing in our next class. So today you can see these equations with respect to small e, coefficient of restitution. Remaining we'll see in next class. Thank you.